Hey, sir, they found it. You better get over here now. Oh, never mind. Yeah, no, sorry, false alarm. Yeah, I thought they were gonna take the fast one. Yeah, you have a good night. Whew. This is the PC Pro. $32,000 worth of PC hardware so fast, it'll knock your socks right out of your sandals. Let's take a look inside at the beautiful power supply provided by our sponsor, Seasonic, who makes great power supplies for everything from entry-level gaming rigs to servers to monsters like this. The 2019 Mac Pro is a thing of beauty, and there's no denying that it's powerful. Ours here is equipped with 28 processing cores, 768 gigabytes of memory. It's got an AMD Radeon Vega Pro Duo, a graphics card so exclusive you can only get it in this machine, and it's got one small problem. Macs aren't known for their bang for the buck, so then even if I had a lot of bucks, 33,000 of them to be precise here, would I be better off with one of these or one of these? With the PC Pro, our goal was to create a machine that beats the Mac Pro in every conceivable way, starting with the case. This InWin 2 2.0 is one of only 300 units in existence, and it's one of the few PC cases that I think is truly striking enough to take on the Mac Pro. The outside is covered in 5mm thick tempered glass that has been vacuum sputter coated to create an incredible one-way mirror that only shows off your hardware when internal lighting is applied. The process is a little deeper than we have time for now, but it's super freaking cool, so watch this video from Applied Science later on. All of that tempered glass is held in place by an aluminum frame that was welded by hand, giving it the distinctive geometric look that it has. Now, hearing words like welded by hand and vacuum sputter coating and 1 of 300, you'd probably guess that this is worth a pretty penny. And at $2,000, you'd be correct. So for that price, how good is it to build in?
Not good, very bad.
All right, so hardware access then. Mac Pro 1, PC Pro 0. Now, Alex, I can't help but notice that we've got 2 monitors hooked up to the PC Pro and only 1 to the Mac.
Yeah, the second one there is just for the post sequence, so you know that it's actually doing something after you hit the power button.
Of course it is. I feel like I know how this is gonna work out, but let's do our power on boot time test. Okay, fine, I'll press that button.
Just give it a second. Yes.
Okay, what did you do?
I just held it for longer.
The good news is that you've got remote access over IPMI, so if you're not, in the same building, you can still remote into it over the network and update the BIOS or, restart it or whatever. The bad news is it outputs to VGA first and then DisplayPort later. All right, boot time is admittedly not a strong point for the PC Pro here. So Mac Pro 2, PC Pro 0. Admittedly, this isn't going very well for us so far.
It'll get there.
Now, one of the toughest decisions for this build was actually the CPU. Threadripper was very tempting because of its excellent single-core performance, overclocking capabilities, and official support for Windows 10. The deal breaker for us was its maximum memory capacity of 256 gigs. Now, for most applications, 256 gigs of RAM is a lot, but the Mac Pro here can be kitted out with up to 1.5 terabytes of memory. And we couldn't allow ourselves to get beaten like that. That's why we chose, against AMD's wishes, the Epyc 7502P, a 32-core server processor with support for up to 2 terabytes of RAM. Now, it adds $3,847.18 to the total of our machine here, but as far as we can tell, its lack of support for Windows 10 is just a validation bottleneck over at AMD, and I'm quite confident that it will beat the 28-core Mac Pro in multi-threaded tests, even if it falls somewhat behind in single-threaded tests. Besides, I think it's fair to assume that anyone buying a 28 or 32-core processor is mostly concerned with multi-threading anyway, right? The main problem with choosing a server processor is that you're usually stuck with a server motherboard. In our case, the Tyan mainboard S8030GM2NE. Now, to be clear, we really like it, and there's even another version of it that has dual onboard 10 gigabit network cards. But the thing is, we aren't exactly using it in its intended application, so certain things like fast boot times, robust I/O, and fancy black PCBs have been sacrificed for things like reliability, high-quality PCI Express Gen 4 capable traces, and heaps of storage options. Let's go ahead and open it up. That is a thick boy of a panel. Dang! Man, there is something positively delightful about seeing 64 threads in Task Manager. And check this out, 1,020 gigabytes of memory. However, keeping a terabyte of RAM cooled is no laughing matter. These 128 gig modules that we're using from SK Hynix run freaking hot. So we're actually using something that I haven't seen since like the Skull Trail days. These active coolers running over top of our dual 4DIMM banks of memory modules here. And I had a small heart attack when I saw that this one was resting on the back of our graphics card, but actually it's okay. Good job, Alex. You covered it in electrical tape, which is definitely an appropriate solution for a $30,000 machine.
Do you want to hear why we really need those coolers? Let's just turn these off for a second.
There's an alarm that goes off at 95 degrees. It's mad, we gotta plug the RAM coolers back in. All right, that's better. We're down to about 50 degrees now. Now that alarm might seem obnoxious, but all the monitoring on this motherboard is part of what allows it to run 24/7 in a server type environment. Besides, we gotta protect these modules because they're over $1,200 each for a total of $9,792 of memory alone in our system. Pivoting to our least expensive component, if we were to 100% push everything in this system, we'd be drawing close to 1,300 watts. Now, normally, we throw a Seasonic Prime Platinum 1,300 watt power supply in rigs just because we can. It'll run most gaming machines without even turning on the fan. Here, we actually need the entire 108 amps on the 12 volt rail and 1,320 watts of continuous power. Now, in real world operation, you almost never actually run every component of a system at 100%. So we're not expecting to see more than about 1,000 watts of power usage at a time, partly because of how the GPUs are configured. More on that later. But it is considered best practice to overspec your power supply a little because they do degrade a little over time. Also, upgrades happen, and a failure, especially in this case, can destroy a lot of expensive hardware. So this unit has a 12-year warranty and only took a $270 bite out of our budget, which sounds totally reasonable in this context. Back to expensive stuff now. This right here is a Quadro RTX 8000. NVIDIA's top GPU with a staggering 48 gigabytes of VRAM and a price tag of $5,500. Just a single one of these should be able to put a Vega Pro Duo in its place. So naturally, we got two. But there's more to it than that. Joining the two together is an NVLink bridge, which is basically a 100 gigabyte per second data superhighway that allows the two cards to not just communicate with each other, but actually share memory, giving digital artists, data scientists, and engineers 96 gigabytes of effective VRAM in a single workstation. That is, it'll give them that if their boss will sign off on the expense report. So we've got two Quadros and an NVLink bridge, which means that NVLink should just be working, right? You might think that by looking at NVIDIA's literature. The only problem is that this guide contains almost zero useful information. Run a command to check if it's working, you say. How? And where do I run this command? Fortunately for us, the guys over at Puget Systems put together a guide for how to get NVLink going, which they created through trial and error without any documentation from NVIDIA. First problem, when enabling NVLink on Quadros, the display output actually gets disabled. So we needed another GPU of the same generation or newer. In our case, this RTX Titan here is gonna act as our display output. Then we have to do some command prompt stuff to enable NVLink on the GPUs, And after a reboot, we can run the NVLink tester that Puget Systems actually made to ensure that it's all working and check the bandwidth between the cards. Huge thanks to those guys for putting all that together. I have no clue how NVIDIA expects their customers to figure these things out otherwise. In a nutshell, everything I just said means that this RTX Titan here is just a really pretty golden display output, bringing our total spend on graphics up to $13,499. Ridiculous. Fortunately, the RTX Titan is also the fastest gaming GPU on the market. So naturally, for our first test, we're gonna see just how well these two computers that are completely not designed for gaming fare against each other in gaming. Ready for the drag race?
Yeah.
All right, run benchmark, 3, 2, 1, go! They're both running Windows, by the way, just so you guys know. That's a lot more FPS.
Yep.
Oh, I'm sorry, yep, it's a lot more. And you can talk all day about how this is gaming and it's not, you know, for gaming or whatever, but more GPU power is more GPU power. That would be clearly beneficial. Oh, nice. That was a pretty one-sided fight. But a W is a W, so it's 2-1 for the Mac Pro. Let's go for the Mac Pro's main draw though, content creation. To test this to its fullest, our video editor Mark, who is admittedly a Mac guy, put together a benchmark for us in Premiere and Final Cut Pro to really test if the better optimized Mac Pro, which does, by the way, have the accelerator card in it, or the much more powerful PC Pro is able to take the win. So we've got a multi-platform audiovisual render kit, or Markbench, as we're calling it. So we weren't kidding when we said that the I/O on this thing is terrible. It's got 2 USB 3 ports, a management network interface, that's not like a network port you can actually use, VGA, serial, and then 2 gigabit network ports. And then it could also have 2 more 10 gig network ports. Lots of networking. That's, what is that, now 3-1 for the Mac Pro?
Yep.
Wait, so I see there's a USB card right here. Is there a reason we didn't install this in the bottom slot?
Yeah, we bought pretty cheap ones and they were causing stability issues.
Markbench, also known as Benchmark. Oh, I love myself. So here it is, the Afterburner card versus 2 RTX 8000s worth of GPU muscle. 3, 2, 1, go!
Keep in mind that this is multiple 8K clips animated with, you know, effects attached to them.
Oh, so you did
Like
the same
grading, yeah.
project
Yeah.
in both pieces of software. I thought we were just doing a simple encode, but we're not. Oh, this is way more interesting then. So we're using 100% CPU right now.
This is using 90% GPU.
These puppies are up at 80 degrees. It is using them.
Perfect.
Okay.
He's
Are
done.
you done?
Oh yeah, done.
I'm at 45%.
That's thrashed.
Oh, dang! I was not expecting that result. Were
I wasn't
you?
either. The script's
Oh,
written.
this is the first time you've seen it.
Yeah, this is the first time I've seen it.
Oh, that's hilarious. Okay.
The script's written as if the Mac wins Markbench.
Oh, okay. The problem with a lot of videos about the Mac Pro, though, is that people that make videos about the Mac Pro are mostly, well, video creation professionals. In real life, video editors, who might observe that the Mac Pro is so much faster, make up only a small portion of the people that need massive computing power for their work. Engineers and scientists, financial analysts, medical professionals, and many others require this kind of power. So for them, how is the performance between these two machines going to differ? We're gonna find the biggest differences in applications that support NVIDIA's CUDA GPU compute exclusively and will not be able to take advantage of the AMD GPUs found in the Mac Pro. For instance, SolidWorks Visualize only supports CUDA. So on the Mac Pro, it took several times as long as it did on the PC Pro, meaning our score is now even. To look at some other workloads, we're leaning on the Spec Workstation benchmark. In many of the CPU tests that are either single core dependent or shorter, burstier multi-core workloads, the Mac Pro comes out ahead. So 7-zip, Blender, Python compiling, and simulations that are just out of necessity single core, like stress analysis because it can't be parallelized, that nets the Mac Pro 11 points. The only thing though is that the Mac Pro only won these CPU benchmarks by a little bit, whereas in anything that required GPU muscle, the PC Pro absolutely wrecked house, sometimes doubling the Mac Pro, giving it a total of 13 points. Woo, 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 woo. Sort of. I mean, here's the thing, guys. Cheerleading any kind of inanimate object is silly, and making the right decision is always going to come down to your particular workload and budget. So let's get back to practicality. As cool as the PC Pro is, I don't think anybody should buy this. I mean, we did find a way to spend $32,000 on a PC, but this configuration isn't going to excel at any one task like a machine that was built with more focus would. Like, say we wanted the fastest rendering machine possible. We would sacrifice a bunch of the RAM and spend that money on additional GPU muscle. Maybe we do need loads of RAM for big financial calculations. Well, in that case, we could ditch some GPU and get a server board that doubles our maximum memory capacity to 4 terabytes. Probably the most egregious waste of money is, of course, the case, which is 100% form over function and is 10 times the cost of a less flashy and more pragmatic one. Though in fairness to us, we were trying to compete with Apple here, when in Rome, right? And besides, at the end of the day, we achieved exactly what we set out to do. Look at this thing. The PC Pro is a nod to excess, and in that, it excels absolutely. Where the Mac Pro destroys your wallet while making massive performance compromises because Mr. Cook and Mr. Wong can't sort out their differences, the PC Pro evaporates your bank account while being the most OP system around. And yeah, it doesn't excel at one single task and definitely has its own problems, but I think it's pretty epic, pun intended. And I want to thank Seasonic for sponsoring this video and you for watching it. If you guys are looking for another fun over-the-top Mac-themed PC video, maybe check out our Hack Pro series. By the time this is out, we should be done filming the finale, and you're going to be able to binge watch the entire thing very soon.